The Trabectome and Trabexl are procedures that are designed to remove a strip of the inner wall, either directly, mechanically, or with irrigation. These procedures are designed to again use either an ablative procedure using microcautery or using double serrated blades to incise the anterior and posterior edge of the trabecular meshwork. These histopathology slides and scanning electron microscopy show the removal and the unroofing of the canal, revealing open collector channel ostia to allow for unimpeded aqueous outflow. The three versions here show the Trabectome, which is the electrocautery device. An insulating footplate here protects the outer wall and is used to pass through the canal, while the ablative tip removes a strip and ablates the inner wall. Trabexl is a procedure that's done without irrigation and is again a dual serrated blade to incise the anterior and posterior wall of the canal. Trabexl is using irrigation and aspiration at the same time, and this creates basically an irrigating goniectomy, much like the Trabectome does, but in this case without using cautery, simply using the dual serrated trapezoidal blades. This may further enhance the angle visualization as well as fluid irrigation through the system. The Trabectome is a microelectrocautery device designed to incise and remove the inner wall of Scham's canal. The sharp tip footplate is used to incise the inner wall here, and you can see the direction we're going in is in a counterclockwise fashion. Once we have placed the tip into the canal, we see the filament now being discharged here as we move the element over in a counterclockwise fashion. We typically use about 0.8 to 1 millijoule and move in a very careful fashion here, following the contour of the angle here, rotating our hand along the incision and ensuring that the footplate is parallel with the outer wall to avoid engaging the sclera and the outer wall. We see now the inner wall has been incised for about 45 degrees, and now we turn the tip here. The sharp tip is now placed again inside the canal here, and the discharge from the filament, microelectrocautery filament, is used to incise and cut the inner wall, typically doing about 90 degrees to about 120 degrees in the nasal angle. Once it's been performed, you can see the so-called cleft form here, the splitting of the inner wall here, showing actually a number of collector channels nicely filling with blood reflux. This is a nice example showing the distal outflow system, the outer wall collector channel positions here, filling with heme as the IOP is reduced in the eye. We typically perform the procedure with irrigation. Viscoelastic is used to protect the cornea, and the inner wall is incised with the element as seen earlier. Again, just with time, we see the blood reflux into the eye from those collector channels. Now we're going to inject some trypan blue through the area of the Trabectome effect, showing the filling of those distal outflow aqueous and episcleral veins, nicely showing patency within the system. Further irrigation also causes blanching of those same aqueous veins, again showing that we've now bypassed the inner wall resistance directly into the collector system, distal outflow system. And when we compare the aqueous episcleral veins in the temporal quadrant compared to the nasal quadrant, we see the blanching in the area of effect.